Cleveland.
Okay, today we are going to check the output power of our newly completed Cleveland amplifier chassis. Here we have a variable power load resistor, and we are going to set it for 4 ohms first. First, we're going to short the end of our test leads to our ohm meter, and we're going to zero it out so the test leads do not affect our resistance measurement. So now we've zeroed it to the end of the test leads. Now we've connected the ends of our test leads to our load resistor, and we check the resistance, and it's not quite 4 ohms. Let's see if we can get a little closer. Turning the adjustment. That would be 4 ohms. Here we've connected our 4 ohm load resistor to the output of the amplifier, and what we'll do is we'll connect a oscilloscope across the load so we can measure the peak voltage and look at the waveform. And I think what we'll do is we'll set up an RMS voltmeter also. Hold on. So here we've also connected our analog voltmeter to measure RMS. Okay, now we need to connect the output of our 1 kilohertz audio signal generator to the input of the amplifier via a 1/4 inch plug, and power baby up. Now that we're warmed up here, we're going to bring up the signal till just about clips here. Back it off till it just starts to break. You can see that our 5 volts per division, so 5, 10, 15, 20, 25, 30. We got about 35 volts peak to peak. Over here we're showing about 13 volts RMS. Okay, so what am I going to write down here? I'm going to write down our resistor, 4 ohms. I'm going to write down our peak to peak voltage measured on the scope, about 35. Alright. Our peak voltage is half of that, which should be 17.5. Our RMS voltage is the peak voltage times 0.707, which turns out to be about 12.4. From Ohm's law, power is V squared. Power across a resistor is V squared over R. So our peak power would be our peak voltage, 17.5 squared over 4. And our RMS power would be our RMS voltage squared over R. And that turns out to be 76.6 watts peak and 38.4 watts RMS. Looks like she's working pretty good.